All right. Welcome to the first and hopefully last week of recorded videos in this class. Today's topic is called the birth and death of the day, for reasons that will hopefully be obvious by the end of this video. And just a broad reminder, our topic these next 2 weeks, How Do Humans Human? Might be a weird sounding title. Basically, the point here is to get some basics down about humans, human body systems, and social systems before we dive into a little bit more specific content later in the course. Um, all right, and so if we were together in class, we would spend some time reading through this and kind of making some fun guesses about what this substance is. I'm not going to read it here because this video will be long enough, but I encourage you to pause it, read through this, and try to guess. And assuming you did that or just don't care to do it, the answer is water if you're interested. And I like to use that as a lead into talking about homeostasis. This is a term you might have come across in other classes before, other studies. Um, Basically, homeostasis is referring to our body's efforts to regulate itself and maintain balance and stability. Balance is very important in the maintenance of life, maintenance of living organisms. And so I guess you can kind of think of this two ways as you can think of it as the process of maintaining that balance, or you can kind of think of it as the balance or baseline. I think either one is fair. I kind of think of it more as a baseline, but it's important to note there's processes to try to stay there. And speaking of processes, there's a whole hell of a lot of complex systems in our body that are involved in maintaining this balance, right? So our body is constantly sending signals around, sending feedback about what's happening, and then the body is responding to that feedback and adjusting things accordingly. And so there's all sorts of systems in the body. Um, we're not going to go through all of these, but just like these are some pictures I found on Wikipedia that just kind of depict how many different systems there are in the body. Um, yeah, so muscular system, nervous system, endocrine system, cardiovascular system, lymphatic system, respiratory system, digestive system, urinary system, reproductive systems, the list goes on, right? And so these don't operate in isolation, they're all sort of interconnected, but they each might have their sort of own unique functions. But point is, all these different systems interact to try to maintain that balance. And there's a lot of things we need balance in. Oxygen and temperature, for example. If you hold your breath, you'll very quickly become reminded of the fact that we need oxygen to live. Things like heart rate, respiratory rate, um, blood sugar, blood pressure, electrolytes, the list goes on and on, right? And I don't know, this is a tangent, this next slide, but just speaking of trace metals and stuff like that, some people have actually sort of done the math, so to speak, on what our bodies are composed of. And that always kind of trips me out when you look at the human body in terms of elements, and what proportion or percentage of our body is made of certain elements. I don't know, it kind of blows my mind. So I just like to mention that. Um, but anyway, there's lots of things we need balance in. To look at just a couple to kind of depict this idea of homeostasis, let's start with temperature, right, and how our body tries to maintain that balance. Um, well, for starters, we can be too hot, we can be too cold, right? And if we're too hot, what's going to happen? We're going to start sweating. Basically, what's happening is the hypothalamus, part of the brain that we'll talk about in a little bit more depth here shortly, the hypothalamus is aware of this and then sends signals to our body to start sweating, right? And then the sweat will evaporate off our skin, which will cool our internal core temperature. And then, bam, we maintain homeostasis. For cold, hypothalamus is once again the hero and tells the body that, hey, we're cold. And so blood vessels contract, and muscles shiver, trying to generate some heat and preserve our temperature, to ultimately increase temperature and maintain that homeostasis, right? So that's assuming everything's going right, but kind of some examples there. One more example with blood sugar. Um, there's a lot going on here in this picture. Um, Basically, the idea or the kind of underlying takeaway here is the pancreas now it releases different chemicals. I'm not actually sure what you would call these, if it's fair to call them a hormone or not. but releases various things to try to maintain and regulate that blood sugar. So for example, if this line going up and down is our blood sugar, and the middle line is our baseline, like the ideal homeostasis or level of homeostasis, or level of blood sugar, as our blood sugar rises, our pancreas releases insulin to decrease the blood sugar. And if our blood sugar decreases too much, then our pancreas will release glucagon to try to increase blood sugar. And so it's this never-ending intricate dance of trying to maintain homeostasis. And so it's just one example of one of those systems. And there's countless systems like this in our body that are helping us out at any given point in time. I guess this graphic I created just to help kind of demonstrate and explain what's happening on that slide. So basically, as things are rising, our body will send negative feedback. Negative feedback, positive feedback. These are terms we use that relate to how feedback ultimately changes variables within a system. Positive feedback tends to, oh gosh, I was going to use the words augment, not attenuate, but I always get those mixed up. Basically, positive feedback kind of ramps things up, kind of adds fuel to the fire. It'd be like, I don't know, yeah, if you have a fire going, it'd be like adding another log. Negative feedback aims to reduce things or change things in the opposite direction. And so that'd be like taking a log out of the fire. And so, yes, you can see here as things rise, negative feedback telling it to decrease. And then as we go past our homeostasis, negative feedback again in the opposite direction telling it to rise, and on and on. And that's kind of this intricate dance of homeostasis. And this is happening in all these systems all the time. And maybe this is a weird analogy, but I don't know. This is a visual I used in another class that I thought might be relevant here. If you think about cars and how many complicated systems there are in a car, and how all those parts have to work together in order for the car to run, or to run in a way that is pleasant to ride, and you're not just like, I don't know, exploding down the road. Human body is kind of similar in that we have all these systems, and all these parts need to get along and play nicely in order for us to function well, and to maintain that homeostasis and well-being. And I guess this works as a transition too. So speaking of cars, our nervous system kind of has a gas pedal and a brake pedal. This sympathetic nervous system and the parasympathetic nervous system. And I suppose I should note too, this is just kind of a high level overview. There's a lot we could talk about here. You can spend entire courses, years learning about human body systems, human anatomy. This is just a general overview of some of these and how they relate to psychology. So I just wanted to mention that there's a lot here, but it's just trying to cover some basics, or it's my attempt to cover some basics. And so that gas pedal and brake pedal that I mentioned, if the human being is the car, the gas pedal telling us to go, the brake pedal telling us to stop or slow down. These are part of the nervous system. There's kind of two parts, central and peripheral, and that sympathetic and parasympathetic part of the autonomic nervous system. I think autonomic, like automatic. These are things that are sort of happening within our body that we might not be aware of or might not have control over, but nonetheless are an essential part of our functioning, as opposed to the somatic part of the peripheral nervous system, which controls our muscle movements. Like, for example, if you're feeling anxious and your heart rate rises, that might not be something that you're purposefully doing. Whereas if you are, I don't know, trying to turn up the volume on the computer, right, that's something that you're voluntarily controlling your muscles to do. And there's a lot here, once again. So to kind of pull out I guess, the basic points here. The sympathetic nervous system is like that gas pedal or like a green light saying go. And this one always throws me off, actually. It feels counterintuitive in my mind. I think when I hear sympathetic, I think sympathy. And I think I don't know, like if someone's having a bad day and you can tell and you're like, you want to check in and you kind of pause to talk to them and see how they're doing. That's why this one feels counterintuitive to me, because I think sympathetic, I think brake pedal. But really it's the opposite here. I'm actually not totally sure the origin or etymology of these words, but sympathetic in this case means gas pedal, increasing things like our heart rate, our breathing, respiration, sweating, our adrenaline, so on and so forth. You can see in this image on the right all kinds of different things are involved in these processes. Um, or actually, yeah, backing up. One example that I think of when I think of this is public speaking. Like, I don't know, some of y'all might love public speaking, some of y'all might hate it. Like if you have to give a presentation in front of the class. If you're the type that doesn't like that, or you feel anxious or aroused when you do that, that's an example of your sympathetic nervous system kicking in. Like, I don't know, I remember I had to take a public speaking class in college, and I don't know why I did that to myself because I didn't like it at the time. Um, I still don't like it sometimes, but point is, before giving a speech, I would feel my body kind of kicking into gear. Right, I would feel my heart rate rise. I would start breathing heavier. I could feel more adrenaline, feel anxious, maybe even feel a little shaky. That's an example of that gas pedal kicking in. Your body's kind of priming itself to act. The parasympathetic nervous system then is the brake pedal or the red light telling us to slow down and stop. And so it's promoting rest by basically working in the opposite direction, decreasing our heart rate, lowering our blood pressure, our respiration rate, our perspiration rate, increasing digestion, um, basically digesting food in states of rest as opposed to preserving that energy in states of arousal, right? And so this would be like using the public speaking analogy. Um, Maybe it starts to kick in like 5 to 10 minutes into your speech when you're starting to feel more comfortable. Maybe it doesn't kick in until after, but eventually we will come back to baseline and um, fall away from that aroused state. In cases like public speaking or these simple things in life that might affect our systems like this. And to kind of zoom in on the parasympathetic nervous system a little bit and um, use that as an example of something else. So we mentioned before that these are autonomic, meaning that we don't necessarily have direct control over it. You can't just like, I don't know, you can move your muscles to turn up the volume on your screen or on your computer. Um, but you can't like, I don't know, just tell your body to decrease your heart rate. Or you can't do that directly, but you can kind of do that indirectly through things like meditation. And so this is a good example to me of this mind-body connection. So basically, like when we're meditating, what we're trying to do is to focus our attention on something. Oftentimes it's our breathing, oftentimes it's our body, like if you're doing a body scan and trying to see where you feel tense in your body, just check in with how everything's feeling. Through that focused attention in cases like meditation, we can relax our physical bodies, right, as we become more in tune with it. And then the inverse can also happen as a result of that. As our body relaxes, our mind might also relax as well. We might feel less anxious. We might feel more connected with the present moment, right? This is kind of, I think, a strong example of this mind-body connection and the fact that through indirect means we can actually um, have some influence or effect on our autonomic nervous systems. And that's assuming meditation works for you. I know some people like it just can't stand it. It's one of those things I've had to practice personally. Um, One other piece here, I don't know, maybe this is throwing too much all in one lecture, but something I wanted to mention that we'll talk about more when we talk about stress. When we're talking about homeostasis and um, yeah, and I guess speaking of stress, one of the issues with chronic stress is that chronic stress can actually alter our homeostasis. So like in previous slides and whatnot, we kind of showed how things go up and down, and our body kind of tries to hover around this homeostasis or that baseline, that set point, you might call it. The issue with chronic stress is that sometimes this like maroon, red, whatever color that is, this line here represents basically overall stress. Sometimes if our overall stress rises and we don't get a chance to recover back to baseline, then that can be problematic, especially in the long term, because as stress continues to stay high and we don't have the opportunity to return to our original set point, eventually what our body will do is basically kind of start to develop or hover around a new set point, which might sound like a good thing because the body's adapting. It's good that the body's adapting, but the problem is that we're not able to return to that original homeostasis. And that term for that gap or that change in homeostasis is called allostatic load, something that can be detrimental to the body over time and have all sorts of implications for our overall health and well-being. And so just kind of one example of how when people talk about chronic stress, what's happening in the body on a homeostatic level that can ultimately lead to all the problematic consequences of things like chronic stress. Yeah, there's a YouTube video there if you'd like to watch more. But like I said, we'll return to that later in the course. Okay, moving forward. We mentioned the hypothalamus before. There are a lot of brain parts in these slides and then also in some of the Canvas content. We'll go in a little bit more depth on the brain parts. I don't want you to focus too much on trying to memorize those. If it's important for your major or what you're studying, I'd say go for it. But just for the purposes of this class, this isn't the main thing I want you to take away. But I do think it's interesting to kind of note and visualize what's happening in different parts of the brain. And so the hypothalamus, when it comes to homeostasis, this is a pivotal part of that whole process. This is a part of the brain that is directly involved in maintaining homeostasis and also regulating our drives, like for example, our drive of thirst or drive of hunger, the drive to drink water, to eat something. It's also involved in the pain response. I used to have slides where we would talk more about pain receptors and things like that, but I removed that to keep this video a bit shorter. But yeah, so this is involved in all sorts of things. Body temperature, we talked about hunger and thirst, metabolic systems, even interpersonal things like parenting and attachment behaviors. We'll talk about attachment and parenting more in this course. I forget when exactly. I don't know, within the next couple months. Fatigue, sleep and circadian rhythm, so on and so forth. Circadian rhythm I wanted to focus on a little bit more. Circadian rhythm, something you might have heard of. If you haven't or need a refresher, this is referring to kind of like our body clocks, like the regular rhythms that we get in on a day-to-day level or on a day-to-day basis. Circadian, if you break that word down, dia referring to day, circa meaning about the day. It's the rhythms of our body as we go about the day. And this is involved in things like regulating our core body temperature, our hormones, like for example, plasma levels of cortisol. Cortisol is a stress hormone, or it's a hormone that is typically used as a measure of stress, like in health research, for example. People sometimes do saliva swabs, and then in saliva you can measure levels of cortisol, and people use that as a biological marker for overall stress levels. Melatonin as well plays a role in circadian rhythms. Melatonin, we'll talk about sleep. I also forget when exactly that's going to be. We'll talk about sleep in this course. Melatonin's directly involved in that, a hormone that is involved in overall sleep and rest. Yeah, I don't know if this is kind of an aside. For what it's worth, melatonin is produced and secreted, created and released by the pineal gland. I feel like I'm always pronouncing that one wrong. So there's a visualization of where that is. But to give you a visual of the circadian rhythm and how we go through these cycles throughout the day. So on this, midnight is up here on top, 6 o'clock in the morning, 12 o'clock noon, 6 o'clock at night. This is just one depiction of the changes that occur in our body throughout these circadian rhythms or throughout these daily cycles. Things we might not be aware of or might be aware of. And this graphic is assuming like a regular, I guess, more typical sleep pattern, sleeping during the night, awake during the day. So for example, if this is midnight, at about 2 a.m., we're in deep sleep, about 4:30 a.m. So kind of like, I don't know, just before dawn. I guess it depends on the time of the year, but that time of night, our body temperature is lowest as we're in deep rest. And then as we get further in the day, and we wake up, we see a sharp rise in blood pressure, we stop secreting melatonin, we get into a state of higher alertness, better coordination, faster reaction time, greater muscle strength and efficiency. So like some people will say this is why you should work out in the afternoon. It's because that's when your body is most naturally primed to actually do that type of activity. Highest blood pressure, highest body temperature, and then as we approach night again, melatonin secretion starts, and then the cycle repeats itself. Again, this varies person to person, schedule to schedule, rhythm to rhythm. Just kind of one example of these cycles within us, and how complex they can be. A fun aside related to that. Here in Alaska, like I don't know, you might notice changes in sleep throughout the year. Like in summer, it might be easier. I know for me, like it's easier to stay up late at night without realizing it because it's still sunny out. In winter, it's easier to fall asleep early because it's not sunny out. There's a reason for that, and it's because I guess there's a lot of reasons for that. One of which is melatonin production in our body and how it's influenced by sunlight. Um, and so, in a nutshell, when sunlight enters our eyes through our pupils, right? Those are the pupils, not the iris. Yeah. Sunlight enters our eyes through the pupils. There's a whole complicated process in which all these signals get sent around in the brain, and we start producing, we stop producing melatonin, right, as we receive that sunlight. And instead, our body's producing hormones to keep us awake. And then the opposite is true when we're not receiving sunlight. So, like when it's nighttime, or if we're just indoors and don't see the sun, then melatonin is produced and we become tired, right? And so, some people have actually said, I've heard some neuroscientists argue that one of the best things you can do for yourself to wake up in the morning is to have like 30 minutes to an hour of direct sunlight. And winter is obviously harder, so maybe like I don't know, 30 minutes to an hour of like a what do you call them? Like a happy lamp. I don't know. Take it with a grain of salt. Do what works for you, but that's just one piece of advice I've heard. Um, yeah, I always ask this question poorly, so I'm just gonna kind of give the answer here, rather than pose it as a question. Um, Something you might have noticed, like on a lot of phones, computers, even on like eyeglasses, if you wear glasses, sometimes you can get blue light filters that filter out blue light or at least reduce blue light. And the underlying idea is that it will have less of an effect on your sleep. Whereas if you're staring at your phone all night and trying to go to sleep, sometimes it's harder. And one hypothesis is that it's because your eyes are receiving blue light, which is similar enough to sunlight that ultimately your brain is getting those messages to stay awake. And so blue light filters then are reducing that, but there's still other parts of the visual light spectrum that we are seeing. And so the question then is, why do those other parts of the visual spectrum not affect us like blue light does? And this is one of those things that's impossible to like prove. Um, but one idea people have is that um, for most of the world, like we'd receive at least some blue light in the form of daylight in wintertime. Again, if you're far up north in Alaska, we're not going to be receiving that. But in general, there's some of that, or that's like kind of a key signal. Whereas if we were looking at fires at night, those are giving off yellow to red light. And so maybe we evolved in such a way that red and yellow light don't have the same effect on us because they have been a source of light in many times and cultures. Whereas, I don't know. Yeah, we can't make a blue fire, or I don't know how to make a blue fire. Maybe there's a way. Um, yeah, I could go off on a tangent. Anyway, I'm just thinking of like my Toyo at home and how sometimes it burns blue. Um, anyway, getting back to this, we already kind of covered this point here. There's a lot of chemical messages involved. There's a whole complicated interconnected process here. Speaking of the hypothalamus, um, there's this axis, the hypothalamic pituitary adrenal axis. These are just kind of showing you where they're at in the body, or in this case in the brain. The brain's in the body. Same logic applies. Adrenal glands down here. I guess right above the kidneys, I assume. Um, this is one axis that people often focus on in psychology, other fields too, but in psychology especially, when we're thinking about this mind-body connection. The pituitary gland is a gland that's involved in a lot of hormones and hormonal control. So it releases hormones like growth, um, thyroid gland, blood pressure, energy, sex organs, on and on. Actually, yeah, I feel like I should have just left that out because that feels like a weird tangent that is kind of unresolved. Point is, it's kind of one example of these axes that I at least wanted to mention. Homeostasis, though, why have we spent so long talking about this, Kevin? That's a great question. A hypothetical student who's listening to this video at some point in the future. The reason we're talking about it is because, for one, it's involved in a lot of human processes, and for two, it's at the core of many psychology theories. One example, drive reduction theory. This one is one of those that feels like a no-brainer. Basically, if we have some sort of need that's not being met, then we need to create a drive to reduce those needs. Just like if we are not getting water, our body needs water to function. So we need some way to tell ourselves to get water, and so we feel thirsty, creating that drive to go and take a drink of water. Or similar thing for food and hunger. Right? If we're at homeostasis and we don't need food, we're all fine and dandy, unless you're like me and you're half Cookie Monster. Um, But then if we get hungry, our body needs nutrients, we get a drive, we feel hungry, our stomach starts, there's all sorts of hormonal things happening telling us that we're hungry. Our stomach might start growling, we think of food, and then we're motivated to go eat a pretzel in the case of this example. Another example from my field, job demands resources theory. This is basically a theory of homeostasis. The basic idea is that on any job, there's a certain amount of demands, or in other words, there's a certain amount of things we need to do, demand, or things that our work or job is demanding of us, and we have a certain amount of resources to meet those demands. It could be personal energy, it could be things like social support, could be personal factors like resilience, motivation, willpower. There's lots of ways we can think about this. But the basic idea is that if we have a lot of demands and we don't have the resources to meet those demands, then we're going to be stressed, right? Or we're going to experience strain, kind of like the fancy term for the health outcome of that stress. And on the flip side, if our job has demands, but we have more than enough resources to meet those demands, then we'll feel motivated, right? This really popular theory in my area is basically a simple theory of homeostasis. This one I wanted to mention, some of y'all might have heard this before, especially if you've taken an intro psych class elsewhere. Maslow's hierarchy of needs, one of those really famous theories in psychology, or I don't know, it seems famous at least. It's hard to kind of see outside psychology to see how much this is talked about, but um, basically it's this theory that argues that we have certain needs and we meet these hierarchically. Or in other words, we have basic needs, and only by meeting those basic needs can we move on to more, um, I guess, what's the right way to put it? More idealistic needs. Like, for example, um, in this hierarchy here, there's physiological needs at the bottom and self-actualizing needs at the top. So, for example, the point here is that it's hard to self-actualize and feel like, I don't know, to deeply reflect on morality, to I don't know, express yourself creatively. It's hard to do things like that when you are unable to breathe, right? Or you are just like absolutely starving, you're absolutely thirsty, whatever it may be. You haven't slept in 3 days, I don't know, right? And so the point is, we have these needs, and by meeting needs in one tier of this hierarchy, we're then capable of moving up to meet needs in the next tier. This is one of those theories that um, has a lot of um, mixed levels of support. Some people are against it, some people are for it. Some evidence support it, some doesn't. It's probably not as neat as this theory suggests. But one thing I like to mention here, and one fun fact about that many people don't know, is this was actually inspired by Txika, if I'm pronouncing that correctly, or Blackfoot ways of being. Maslow spent a great deal of time with Blackfoot people and noticed some very substantial differences um, between his experiences in the Blackfoot community and those in, I guess, more broader dominant culture at the time. Um, yeah, and so for what it's worth, I wanted to mention this. I encourage you to check out this article. We might have it as an assigned reading. I'm not sure yet. I have it in the past, but we'll see. Um, anyway, so speaking of indigenous perspectives, I wanted to give a callback to this textbook, which we've kind of, I don't know, referenced or referred to at various points in the course. Something unique about this Indigenous American perspective on psychology, or unique compared to Western psychology, is it in that it very much integrates cycles, right? In this example, cycles of time. Um, I don't know, for what it's worth, uh, the more I've looked at this over time, the more I've kind of had a different appreciation or perspective for it. One thing that this makes me think of, or one, I guess maybe a better way to say that is something else that makes me think of this is the Gaelic calendar. Um, I don't know, just personally looking into my own ancestry and stuff like that, this is something I've come across, and I can't help but notice some similarities. Um, yeah, and so I don't know. Yeah, it's one of those things. I don't want to make assumptions and interject right here, but I do wonder if there's some things we can add here that might kind of give a bit more context or meaning to this. Um, and if you're like, I am not Gaelic or I don't give a shit about the Gaelic calendar, that's cool. Um, I don't know. This is an aside, but this is a universal calendar I found on Wikipedia that tries to incorporate a lot of different calendars because there's been a ton of calendars in different cultures and times. Um, so I don't know. I won't even begin to interpret this because I can't even begin to understand how to interpret this. But if you'd like to dive in more, feel free. But in the spirit of talking about cycles, you might think, what are some cycles in humans or in nature more broadly? For starters, one we already mentioned, right? Circadian rhythm. We go through these daily cycles. Sometimes these are hard to maintain, such as due to, I don't know, things like work. If you work night shift or if you work a couple weeks on, a couple weeks off, right? There's different reasons this might be hard to maintain, but this is a natural rhythm that our body tries to maintain. Um, and there are other cycles in humans too. For example, in females, menstrual cycles. Um, I won't be I won't begin to interpret like everything that's happening in this graph um, because I just don't have personal experience with it. But just kind of demonstrating the fact that there are these um, cycles and there's all sorts of different hormones and biological activity involved. I'm gonna stop because I feel like I'm gonna dig myself a hole if I try to um, speak any more on that. Um, and speaking of sex, I guess, and a different kind of sex, the sexual response cycle. Here it's comparing sexual responses in males and females. Something that's been researched a lot, and basically the cycle of sexual activity, um, ranging from excitement to plateau to orgasm. Um, Speaking of what happens in bed, sleep cycles, right? That's another example of cycles. Um, Again, we'll talk about sleep more in depth later, but different sort of stages of sleep and how our body cycles through those throughout the night. And a general theme there is that the further we go in any sleep session, I guess you would call it, the more REM sleep we're getting, rapid eye movement, which is when we have that vivid dreaming. That's a really essential part of sleep. And I guess speaking of nighttime, lunar cycles, I don't know, one example of cycles in nature. Um, there's all sorts of debate about how much these affect human beings. They certainly can affect other organisms in nature. Um, I don't know, and it's one of those things. People have tried to research and find so many different answers that I don't think there's any right answer to whether or not these affect us. I think it kind of depends on the person. Um, yeah, and I guess speaking of nighttime and its inverse daytime, or how much nighttime can vary in Alaska. We go through cycles in I don't know, broadly in natural systems. So like, for example, this is from a website called WeatherSpark that I really like. I'm kind of showing sunrise and sunset times and basically how much twilight, nighttime, and daylight we're getting throughout the year. And so let's see, we're in, what is it, almost October, so we're like right here in this. Um, yeah, and so with that, with the changing seasons come changes in average temperatures. This one I just thought was funny. That website has a beach and pool score, and um, maybe surprisingly, maybe unsurprisingly, Fairbanks does not have a good beach or pool score. Um, so I don't know. If you moved here for the beaches, I got bad news for you. Um, but yeah, more broadly, our Earth's orbit and the seasonal cycles that come with that. Um, yeah, the circle of life, right? I don't know. This always makes me think of Lion King. If you haven't seen Lion King, um, I don't know if it's worth watching. I haven't seen it in over 2 decades, probably. But the term "circle of life" always makes me think of that song and this scene. "Circle of Life" is a song from that movie. Um, but you can think of "circle of life" in terms of like um, from birth to death, right? And how this cycle repeats itself in all different kinds of organisms. Um, and we talked, I think, last week just about how all living organisms today have a common ancestor. This is kind of a different depiction of that. This is just something I came across when I was looking up stuff for these slides. This is a graphical way of viewing all the different, I guess you'd say, types of life or different living organisms and how they're categorized in science. Um, so yeah, I guess a very different but literal interpretation of the circle of life. And to wind things down and on a, I guess, more uplifting note, speaking of seasons, we are heading into the darker part of the year. We're heading into winter. Um, when I was reading through this book the first time, there was a quote that I really enjoyed that I don't know, I like to mention this time of year. Um, the indigenous perspective of time as cyclical is much different than the mainstream perception of time. The lesson in the cycles of the seasons and the other cycles of life is that time flows beyond the end of the cycle onto another cycle. Winter does not mean the end of time, it is an ending of a cycle and the beginning of another. And then, yeah, this piece here, um, kind of summarizing cycles allow for multiple second chances. Not everything rides on getting it right this time. I don't know. I really like this quote. Um, and yeah, and I've started incorporating it in this course. Just, I think it's a nice reminder to be compassionate with ourselves, be a bit more forgiving. I know the academic environment often can be, um, and I guess this is true more broadly, but speaking of academia, since that's our context, we can put a lot of pressure on ourselves to get things right, to get things perfect. Um, and I don't know, I think it's a nice reminder to kind of relieve some of that pressure and just focus on continuing through the cycles and taking up those second chances. How eloquent, Kevin. Thanks. We'll stop there. See you next time.